Hello, in this video we're going to look at a solution to this problem, which is centered average. It's a list 2 problem under the Python section of CodingMat. So let's start off by making sure we understand the problem. What we need to do is we need to, given a list, we need to find the centered average. And what they define the centered average as is it's the average when you remove the largest and the smallest number from the list. So one way to do this is essentially we can find the sum of the list and subtract the largest and smallest elements. Then divide that by the length of the list minus 2. And the reason we have to divide it by the length minus 2 is because when we remove those 2 elements, the length is changing. So if we look at that kind of explanation of what we have to do, the first thing to say is, well, what do we have to find? Well, we have to find the sum of the list. And that's a pretty straightforward algorithm that I'm hoping we're becoming comfortable with. And to find the sum of the list, we simply say for I in range, 0, comma, length of nums. And we say sum is equal to sum plus nums at I. So there we go. That's the length of our list. Sorry, that's the total of our list. Let's define the sum as 0. We'll initialize it, and then we'll just return the sum for now. And of course, I hit that and everything's wrong. So we need to find the sum of the list. We also have to find the maximum and minimum value in the list. And this is a really important technique that you want to develop. Now, what I'm going to say here is that it turns out Python has a really nice, simple way to do this. And you can leverage this. So what I could do here is it turns out I can say max is equal to, actually let's call this mv for max value. And you'll see why I changed that in a minute. mv equals, well, if I write max bracket nums, it turns out if I pass a list into the max function, it returns the maximum value in that list. Min value, let's just call this min v, max v and min v, equals min bracket nums. The reason why a lot of students, when they do this, they run into an error because what they do is they call this variable max instead of max v, and it actually gets confused because then when you invoke max here, it doesn't know if it thinks you're trying to access that variable, not the function, which is contained somewhere else. So make sure you never call your variable max because that can get a little confusing. So I find my max, find my min, and then what I can do is instead of returning the sum, I'm going to return the sum minus the max value minus the min value divided by the length of nums. And because I'm subtracting 2 values from the sum, I'm going to minus 2. Now, if I run this, it's going to be wrong again. And the reason it's wrong is because of order of operations. We want to actually put brackets around the numerator, brackets around the denominator. And if all goes to plan, there we go. Now, even though there's a shortcut for finding the maximum value in a list and a minimum value in the list, we really want to make sure we know how to find the maximum minimum values by traversing the list. And this is because if you kind of transfer this problem to other languages, they don't necessarily have this nice convenient built-in function. So what I'm going to do is I'm going to actually code this in a less efficient way to find the maximum value. And I'm going to do it a couple ways along. Okay. So what I'm going to do is I'm going to do the same thing where I define some max value and some min value. And the temptation here is to initialize both of these to 0. And I want to stress that you don't want to do this. You always want to initialize max and min value to an element in the list. If you initialize them to 0 and your list only contains, if you initialize the max value to 0 and your list only contains negative values, then what's going to happen is that 0 is going to stay as the max, but it's not an element in the list. So by saying that your max value is initially nums at 0, you're guaranteed to end up with a max value that is a number in the list, and that goes for the minimum as well. This is a really important idea. So what I could do inside here is I could say something like if nums at I is greater than max v, then I can say max v is equal to nums at I. And I can take this code and I can duplicate it with if nums at I is less than min v, I can say min v is nums at I. And in theory, this should work. So what I'm doing is as I look at each element using that loop, I'm assessing if it is the maximum or minimum value. Now again, there actually is a more efficient way to do this, is instead of writing this if statement, what I can do is I can use that built-in function max here, and I can say max v is equal to max bracket max v, so my current maximum value, comma, nums at I. And that's what we typically do if we're going to do this, is we're actually going to use the built-in function as opposed to writing that conditional statement. So min v equals min, bracket, min v comma num set I. And I run this, and it works. So again, this is not necessarily the easiest way to do it, because I have that built-in function to pull out the maximum and the minimum value, but it's a really good exercise to make sure you understand how to traverse a list and find the maximum and minimum values. Because, I might be asking for a different thing where there isn't a built-in function, and this idea of looking at each element in sequence and making a decision about it is really important. Okay, now all of this said, it turns out you can do this coding back problem with one line of code, and let's end this video by showing that. So we're going to take all of this, and we're going to delete everything, and it turns out you can return, and there's a nice built-in function that says, return the sum of nums, that will calculate the sum of nums, plus the max, minus the max of nums, it's going to pull out the maximum value of nums, minus the min of nums, if I can type here, this is going to give you the min of nums divided by the length of nums, minus 2, put all these things in their proper brackets, and there you go. I really want to stress in closing that if you don't see this one-liner solution, that's okay. It's at this stage, you're far better off to understand how to do this using loops than to simply plug in this one-liner and use the built-in functions. The one-liner will come in time, and the more you practice, the more you'll come across convenient functions to do some of the work for you. That's why I love teaching this stuff, because I'm always learning new things. And on that, I hope you have a wonderful day, and as always, don't hesitate to ask any questions.